We're back here again. Today we're going to be solving another Leetcode problem. It's going to be a dynamic programming problem because that's the current topic we're um solving. So yeah, let's start it. Today I'm gonna solve two best non-overlapping events. You guys can see if you guys solve it. But yeah, it's my first time seeing this problem. So let's start it. You're given a zero index to the integer array where events at I equals start time and time value. The ith event starts at start time I and then ends at end time. If you want to attend this event, you will receive a value of value. You can choose the most two non-overlapping events to attend such that the sum of their values is maximum. Okay? Um Note that the start time and the end time is inclusive. That is, you cannot attend two events where okay, so a max you can pick two events, right? And here okay. Okay, let me think. Okay, so the first thing is I know it's gonna be sorted because if it's not sorted, what's the point of starting from 1 to 3, 4 to 5 again to check 2 to 4, right? So it's gonna be sorted. The constraints are pretty high, so there's no way of having a prev if you want to do it in for loop. No. Hmm. I mean, I see you can do it in for loop. But I also think that's gonna show me in runtime or TLE. Let's see. Because the constraints are high. I can't lie. The constraints are high, and the start time and end time. So, if you guys watch my previous videos, what I learned is using a for loop in recursion is usually pretty bad, right? Because you can make unnecessary checks, and it's overall bad. So, even if you think like once you buy it, you can just see what can be the um next index that we can start making choices. Wait. This is pretty straightforward though. Like, so we want to do it in knapsack, right? Instead of for loop checking everything, um, you can do it without a pre, right? And even if you, yeah. So we want to do it in knapsack, right? So let's first create a integer function called events and index, right? If index greater or equals events dot length, then we return 0. If we have the option to not take, equals f of events and index plus 1, and we have the option to take, because when the first um the first option, we always have the option to take or not take, because we didn't choose it time before it or event. So this would be also take equals events at index and 2, because that's the score, right? And we can see, right, if we take this, instead of keeping a track of pre, or we can just straight go to the next index where it is available, so we don't need to worry about that pre stuff and for loop. So if next is not equals no, let's say -1, then we do take plus equals f of event and next. Now let's create a function called next equals f of events index. I equals index, I is events length. Now this is where you use binary search, but just to demonstrate, I'll just do so you guys can understand. And I and 0 greater than event at index at 1. So we can do next. Um, this is not greedy, just to make you understand, because like if you have a event available on that time, right? There's no point of just taking it. What if it's too long? But if you skip that one, you could have taken a better one. So therefore, this is not greedy. It's your negative one. First, we gotta sort the array. Sort events. Let me search how to sort an 3D array based on the first element. Java. Say 2D. Arrays. Dot sort events. Row and row 1. Great. Let's do int. Now we can just return f of event as 0. Okay. Oh. Int. What next takes in oops, let's do this n and then events and index. Okay. Nice. Now, all we gotta do is just memorize a singular DP. Also, just to let you know, if the constraints are high, right? You can only take the prev as a max. Like, you can memorize it. Think of it as like this, right? Once you see a dynamic programming problem that has constraints greater less than or equals 10 to the power of 5, right? Greater than 10,000, then you can do 2D or 3D. But remember, only one of those integers can reach or have the size of 10 to the power of 5. The rest has to be less than 1,000. So here, we can only see, one index, right, has the potential to reach 10 to the power of 5. So it gives us that we cannot use prev, which you guys might think, oh, let's say use a for loop, but that's also gonna give us TLE because for loops are slow in recursive functions, and you check on necessary unnecessary things, and also when you have to go through the array, right? It's kind of slow. So like how do I explain this? You don't need to go through everything, right? If you go through everything in the recursion, that's gonna repeat, so it's gonna be pretty long. But if you go through everything in a separate function, um, you're not gonna waste time, right? Because if you go through everything and found out, um, like, find out that it's not possible, right? Then there's no need of doing it again and again. But if you use this function, it'll be much faster. You'll understand. Like, just like try as many dynamic programming problems as possible, and then you should be set. So dp go to new integer events.length. Nice. Let's try submitting it. Wrong answer. Oh, you can choose a max to okay. T to 1 T. Oh, wait. Oh, guess we gotta do T2. You can use another variable because, as I told, the max could be 1000. So this is 2 here. T. T. Yep. Submit it. Okay. As I said, we can use binary search. So it's not. Okay, for here, let's try using binary search then, shall we? When left equals index plus 1, right equals events dot length minus 1. Right. And mid equals to left plus right divided by 2 if events add mid and 0 greater than events index 1 mid. What? That took long. Just need to do a little bit of cases. Okay. Nice. Hmm. Oh. Okay, now it should work. Yep. Oh. Well, that was a problem I've been trying to solve for the last 3 days. Kind of like makes me annoying when I see it. I want to solve it. So it was an interesting problem. Trying to use binary search. I think that's all. You guys can rewatch the video if you didn't understand, which I think no one would. But hope you guys learned something new. As I said, try to avoid using for loops unless the problem says you must. Right? Here we don't need to go through every part, right? We just need to go through parts that only are allowed, so we can do this with a faster function. Yeah. So yeah, I think I'll see you guys tomorrow. Just submit it one more time. Yeah. Alright. Peace.